At a zone that appears to be overheating this morning on the ninth floor, nurse's station area, I believe. So we're going to zoom in on the ninth floor. And see the update. This area 123 appears to be warm. In fact, appears sometimes to be chronically warm. Let's take a look at where we're at with this to see if we can find out anything to improve this chronic orange and yellow condition that we see. So, over the past 2 or 3 weeks, I've seen this area orange a lot. Um, so we're looking at supplier temperature of 52.3 degrees coming from the cool source, which is air handler 2. Uh, this week we commissioned air handler 2, so we know this is live data from that particular supplier sensor on that air handler. We look over here, we've got about 53.2 discharge air temperature. Typically, we could have up to half a degree error between these two sensors. So we're looking at a tiny amount of heat gain in the ductwork as it's distributed in the building. This is the ninth floor. It's pretty close to the penthouse, so we don't see a lot of heat gain there. And we see that the damper is open 100%. So uh, design-wise, this was designed for a 55-degree supplier temperature most of the time. So this actually is improved over design, and the unit basically damper is open, fully open to do all the cooling work it can do in the zone. So if we go back briefly and we look at the floor plan, we're going to go ahead and show the supplier ductwork. This is coming right off of the main supply trunk, the vertical supply trunk, over to a constant volume box that's now been um, changed over to a variable volume box, and approximate location of where the diffusers are. Okay. So going back into the zone, we have to understand that this system was designed before computers. So the amount of electronic equipment in the nurse's station is going to add a significant load. One personal computer can add up to 1,000 BTUs per hour. One person is usually around 3 to 600 BTUs, so that's nearly two people load, and there are probably equivalent to 10 PCs or 10 pieces of electronic equipment kicking that out. So it is occupied. It has greater occupancy or heat load than what it did before when it was designed. So we have to keep that in mind. We look over here and we see orange, and we see what looks like the area is not satisfied as much, not satisfied as much as it is satisfied. So over 50% of the time, it's not in the green space. It's not really in that comfort range. Well, let's take a look. So right now we have a zone temperature of 73.2, which is actually not bad. What we don't know yet is what the relative humidity is in the space. So we don't have our VOC and relative humidity sensors at our two locations on each floor in the hallway. So this will give us an indication of comfort load. If the relative humidity is above 50% or 55%, then it creates an atmosphere that allows less or diminished evaporative cooling of sweat. So we try to keep it 55% or below. Usually we try to keep it below 50% in the summer, but it's just tough depending on what the workload is of people as well as the building envelope. All right, so let's find out why we're in the orange zone. So what we're going to do here is going to go up to the logic and just quickly look at the set point block here. And we can see that's where our orange color is actually coming from for that thermostat image. And if we click on it and take a look, we're basically going to see that right now their comfort range, they've adjusted their thermostat, and their comfort range they're saying is 71 degrees. So they're about 68 to 71. That seems like a narrower range than I think we agreed to put on the thermostat. I don't know if somebody's changed this or not, but we'll need to go back and look at that just to verify it. So what they've done is they've basically gone to the thermostat and probably turned it to the bottom. So let's take a look and see if we go to trends. We'll go to the view here. Not sure why we ended up in the configure tab, but all right. So let's look at our zone trends here for a moment and see what led to the system or the zone being not in green, but being off. Now this is taking a little while to load up. They are working on and doing downloads on other floors, so the processing duty of the network's a little busy today. All right, so we were in the orange. This is pretty much just spanning left to right of about a 24-hour window for the zone. So we can see we were 73 yesterday. We were cooling down. We were here was the optimum, cooling. It was 71 or below. So we wanted to be between the 68 and the 71 here. So we can see we were yellow till we started to creep down there. Finally, we got to that area where we could start to turn green. And this should have reflected it. I have a feeling this is probably a delay or a hysteresis, kind of a dead band, to make sure we were in it before it actually turned green. So we were in that area, and then boom, sometime at, let's see, 9:40 p.m., perhaps a shift change, someone came in and said, nope, I want this space to be maximum heating rather than maximum cooling. So they changed that, and of course we very quickly drifted into the green band or heated it. We should have a hot water. We don't have a hot water valve here. Let's just add the hot water valve quickly. Let's go down here to, oh yeah, this is one of the zones. Let's see. So we're going to add to subparagraph 2, we're going to add this trend log. Whoops, not that one. The not used. Okay. I just happen to know from previous experience that not used happens to be the hot water valve. I'm not sure why this database error is persistent. I found this in some areas and some not. And the way I've been able to verify that is going to the logic and scrolling down to the heating section, the hot water valve heating control here in this section, and seeing our output going to a point called not used. So incorrectly tagged in the system is the hot water valve. Now I know that it is because it has a reference name hot water valve here. And I also know that particular analog output goes to the hot water valve. So why I've reported that to the programmers, I'm not sure why they haven't corrected that yet. But let's move back to the trends and see if we have a hot water valve now recorded on our 24-hour trend. Four, 5, 6, 7, 8, 9, 10 seconds. It's updated, and we have new data here. So we have the not used. So now we look at and see the green band here of the hot water valve definitely went to, looks like 100% very quickly. So again, this box, if we look at the zone damper position, let's see, it looks like it went to minimum heating, right? And then it went to minimum air, but maximum heating coil to bring it into the space, okay? So this here area right here is where we spend our energy, right? Right there, getting it at the set point as quickly as we can. How long did it take? Probably took, this is fighting me a little bit here, 9:40 to about 10:40, something like that. So it took an hour to get to set point, basically because it went into minimum reheat and not maximum reheat. Maximum coil to get a very high discharge air temperature, but, and I'm not sure we have that mapped. Yeah, we do right here, discharge air. So probably limited a little bit by discharge air temperatures, not that high, to get it to that set point. So to me, that's a little sluggish. We have two conditions here. One is the control of the controller to decide how much air to put in the space, and the other is the static pressure of the entire system, making sure it has enough. Remember, these are pressure-dependent systems. We can't read the exact value of CFMs coming in and make a calculation to do so. We just have to tune these so we don't give people bursts of heat, but we have a steady climb of BTUs per hour of comfort change. All right. So we did get into the comfort range, looks like all night long, and then boom, what happens? Maybe a shift change again, 7 a.m., the new person comes in and says, boom, I don't want that. I want maximum cooling. I think it's warm in here, right? So at that point, I'm not sure what the outdoor air temperature is. We could go back and look and see if it was 65 degrees out or what it was this morning. I imagine it was a little bit cool, but still someone came in and said, I want maximum cooling. And we see the box respond and basically remove all the heating. So the heating goes down to nothing here pretty quickly. And then we have the damper position opening to max, right? Here's the discharge air trend. Let's see, that's discharge air set point, and our discharge air temperature. Where is it hiding at? I missed it over here. Yes. So our discharge air temperature, boom, drops down pretty quickly to that 55 or less, and matches very quickly. So the machine controls very, very well to in the cooling very aggressively, maybe a little bit more aggressively than in the heating side. So that's just the way the system is tuned right now. So we can make minor, very little adjustments to change that. So now we're in the orange zone, and if we look at the graphic, we can see that we've been, for quite a while, we've been basically in that orange zone. We're down to 72.9. We've got a ways to go to 71. So this is where the box is doing its absolute maximum, and it cannot overcome the load in the space. So now we have to evaluate, is this box too small for what that space is now? Do we need to resize it to bring in more fresh air, more cooling air? We can go down and do a balance and find out if it's been limited against its base design. It probably is fine. It probably puts out the CFM that it was supposed to. But I imagine what we're going to find is that the load between computers and people have changed from original design. And this is why it probably runs chronically orange. It doesn't get enough cooling BTUs to the space because the space is hotter than what the design is, even though we're compensating it with colder air. All right. So that concludes this look at VVZ 9C7 on the 9th floor, nurses station area.